there are parasites. And when you say that word, people go, wait, parasite? We don't want to put a parasite ever into our lake. But the thing is, people don't know that parasites are the most specific of the natural enemies that will kill zebra mussels.
Welcome back to English Insight, where we dive deep into the challenges that face our waterways. Today, we're joined by Dr. Daniel Molloy, a world-renowned biologist and the pioneer behind a truly innovative approach to battling invasive mussels. For decades, quagga and zebra mussels have wreaked havoc on the aquatic systems infrastructure and the fishing experience itself. But Dr. Molloy has found a biological key into fighting back. In this episode, we explore how his work with the naturally occurring bacteria could revolutionize how we manage invasive mussels without harming native fish or the environment. We'll also discuss where these treatments have already been used, what types of water bodies can be treated, and the potential for expanding this approach to fighting emerging threats like golden mussels. Whether you're a scientist, angler, or just passionate about preserving our waters, this is a conversation you won't want to miss. Dr. Molloy, welcome.
Thank you. Thank you very much.
So, before we even get into the background, the one question that I have is, are you familiar with the golden mussel?
I'm quite familiar with it. I follow the literature on it. It's a mussel that came from Asia. It's causing enormous problems in South America, and now it's in California. It's the first place in North America, and it's very similar to the kinds of mussels that I work on, zebra mussels. So there's a lot of similarities. Yeah, so I'm familiar with it, but I don't work on it directly. As we'll see in this discussion today, I am very focused on my area of expertise, which is the biological control as opposed to chemical control of zebra mussels in North America.
Got it. Thank you so much for that. To start, can we go with a little bit about your background and how you got involved with invasive mussels?
Yeah. I'm an infectious disease specialist. I understand how infections are transmitted from one organism to another. When I tell that to most people at cocktail parties, they go, oh, you're a pathologist, you work at the hospital. No, I only work on invertebrates, something that doesn't have a backbone. And the reason I'm working on their diseases and studying their diseases is they are pests. I pick out certain invertebrates that are pests that people are using chemical control methods to manage, to kill. And of course, chemical control methods typically are very broad. They have lots of non-target impacts that are negative. And I work on finding a natural method to control these pests. Okay, so that's my background. I'm a biologist. I work in water. The invertebrates are in water, and I specialize in the diseases that they have. And can these diseases, if they're very specific, be used to control them? That's what I do throughout my entire career.
What got you interested in working with, I mean, mussels, I imagine, isn't something that schools are talking about when you went to school, or, it's
Yeah,
just not a common thing.
yeah. My PhD is in bugs, okay? That's my specialty when I was in graduate school. But it's not like I studied how to tell one bug from another. I was studying the diseases that bugs have. Always had this interest in infection. Back in the 1990s, actually, these zebra mussels were first found in North America in 1988. And early in 1990, I was approached by the New York State Department of Environmental Conservation because I had some successes in coming up with biological control methods for controlling black flies and mosquitoes. I mean, everyone's familiar with mosquitoes, but are you familiar with black flies, for example? Do you know what I'm
No.
talking about? Most states have them, but most states don't have problems with them. In New York State, especially, these little tiny flies, obviously they're black, hover around your head, they bite you, and especially in the neck and the ears, etc. So they're a pest. So I came up with a biological control method to control these black flies in New York State. Then when zebra mussels came to New York State, roughly in 1990, I was approached and we have no way to control them unless we use chemicals. That's what the power plants in New York State were telling. That was their line. So I got funded to look for ways to control these zebra mussels without using chemicals. And that led, because I'm a specialist in infectious and non-infectious diseases. That's how I got invited. They invited me to do some research.
So before we go too far into the research, they were having issues at power plants. Is that why they
Yes,
contacted you in the first place? So can you
exactly.
elaborate on what those issues they were having was?
Yeah. You see, these zebra mussels, again, found for the first time in 1988, and they probably came in a little early. You don't find them the first year an invasive species comes into someplace. So in the early 80s, they probably came in native to Eastern Europe and probably ballast water in transatlantic ships brought them to the Great Lakes. They were found in Lake St. Clair in 1988, which connects Lake Huron and Lake Erie. And then it's just a matter of time. The current took them to a near state. And they're the first, the reason they cause so much problem is because they can produce little threads to attach to objects underwater. It is the only two-shelled organism, so a bivalve, two shells, which can attach. Before they arrived, there was no bivalves that could attach in fresh water to anything, a hard surface. So they go inside pipes, they clog pipes, so they cause industrial problems by clogging pipes. Like you can think of a power plant, let's say a nuclear power plant, and they're having their cooling water pipes clogged up with these mussels. So obviously they have to do something. And in 1990, the only thing they could do was put in some chemicals, and the chemicals go into the power plants, and they do clean those pipes very well because they're biocides, chlorine, essentially. And then they come out 20 minutes later, they're back out into the river or the lake. So that's why they invited me. And that's the problem. They produce threads. If you're familiar with walking along the coast, whether it's the East Coast or the West Coast, at low tide, you see mussels, and they are naturally in the environment. They're native. But this is the first time you had a mussel that could attach to something underwater, freshwater in North America. And that's then not only that causes problems, but this is where I get involved in that the chemicals they put in, do clean the pipes. There's no doubt about it, but they come out the other end of the pipe into the water body and cause ecological problems there. So I hope I've adequately explained what's the problem they cause.
Going back on, so you initially got into this to treat power plants. Now,
Yep,
because the mussels were clogging up the pipes, right?
that's right.
And,
I was asked to do research because I had succeeded in similar projects in the past.
and were these mussels you were working on, were they zebra or quagga mussels, or does it matter? They were both.
Initially was zebra, and then I started to work on quagga mussels also, and I'm still working on them again, right? On this other approach, which is really the only thing that has had any hope of working. If someone comes up like myself with a biological control method, which you apply it, it spreads by itself. You don't have to go back. This all sounds like hunky-dory, unbelievable, but it is possible if I can pull the rabbit out of the hat. I can do this.
So we'll get to that. The question I have before there is when it comes to something like the pipes in the power plants,
Yeah.
how long are these pipes? Like how deep into these pipes are these mussels?
Well, of course, they initially start to coat the pipe right where it's sticking out into the water because they need the raw water dependent infrastructures, whether it's a factory making widgets or a power plant that needs cooling water. They suck water in primarily for cooling that needed inside the facility. So you'll have a buildup of mussels right there at the very beginning of the pipe. And then they just work their way down the pipe and get into very fine, small openings and clog those. They have shut power plants down initially back in the 80s when they were first discovered. They were shutting the plants down, which is kind of dangerous again. And then they decided, we got to keep chlorinating to keep them open, and so. Yeah, and then again, these chemicals will keep the pipes clean, but it's the environmental impact of those chemicals that disturbs me as an environmentalist. And that's why I've worked on finding safer methods. Much more hard to find these methods again. Research is very challenging.
So, because a question I get asked often, if they clog pipes and it's such a problem, can't we just take like a bore brush and clean the pipe out? But from what you're saying, it sounds like they're way too far.
Totally impractical. Totally impractical. Totally impractical. And people, they're very sensitive to heat. So initially, again, this goes back 30 years ago when the problem first started, they said, wait a minute, why don't we just put hot water in? And we can kill them that way. Or since we're bringing the water in to cool inside of the facility, some motors, why don't we just backflow the water, stop making widgets or whatever, and just backflow that hot water in the reverse direction and kill the mussels because they're very sensitive to heat. However, engineers say, wait a minute, don't try to heat this water up either way, going in or reverse it, because you could have pipes collapsing inside. They're not designed to hold hot water throughout the entire length of the pipe. And so they said, whoa, we can't do that. So people have thought about all sorts of ways to control them, but really it comes down right now to chemicals, basically. There are people often ask me, well, what do Europeans do? Because they've been there for centuries. And there are engineering things you can do. Instead of, sometimes the mussels are not all the way to the bottom. If it's an extremely deep lake in Europe, you could, instead of just sucking water off the top, where the mussels are, if you put a pipe much further down, you can take water in where there aren't any mussels, and then your pipe won't be infested. Or if the water inside that pipe moves at a great speed, let's say 4 feet, 6 feet a second, very fast, these mussels cannot really hold on inside a pipe. So there are engineering things. There are sand filters. If you could put the end of your pipe under like a football field size of sand, water can go through and those mussels will be filtered out into the sand. So there are methods, but in all practical cases, it's using chemicals. And that's what I'm trying to find a way to stop, find a biological method.
And like retrofitting a lake to do any of those things would, I imagine, cost.
Very expensive. Like, for example, even though they've been in Europe, they haven't been in every European country. Switzerland just got these zebra and quagga mussels in the last few years. These are the problems they're faced with. What are we going to do? And it's going to be very expensive, no matter what they do. It's going to be very expensive to try to control this problem.
So, in your mind, the main best option we have is going to be chemical treatment.
It's the most effective, but you have these impacts on environmental degradation rather, when you're treating them with the chemicals. There is no chemical that's just going to kill zebra mussels. When it comes out the other end of the pipe, it's going to kill all sorts of things. So that's just with power plants. Right now, Idaho, out your way at least, I'm in New Hampshire, is having problems. They've got quagga mussels in a river out there, and they are applying copper products directly to the river. They know fish will float. But they're so interested in trying to get rid of this infestation in the river. I think it's the Snake River. I'm not sure about that. But they know there's an enormous environmental cost to this, and they feel stuck that this is their only option to try to kill them in an actual river. Very few people have ever eradicated these mussels anywhere. It's very, very seldom. There are very few cases of it, and they're trying to do that, and I wish them well. Their methods are very destructive to the environment. They know that, but they're desperate to try to get rid of these quagga mussels in their river.
My question comes in, a lot of this water ties to our drinking water in one way or another. Is that accurate?
There are drinking water facilities that absolutely have problems with zebra mussels and quagga mussels, and sometimes they up the amount of chlorine that they're putting. They're putting chlorine in anyway to kill potentially infectious diseases in the water that you're drinking. So sometimes they up the quantity, the concentration of chlorine. Chlorine, as many people know, produces byproducts which are carcinogenic, so potentially causing cancer. And they do their best after the chlorination of the drinking water. They do their best sometimes to dechlorinate it before you drink it. But again, this adds, so that it's less potentially carcinogenic. But this costs a lot of money. There are factories that are affected. There's drinking water facilities, et cetera, by these mussels.
So I know in the past you developed a new way to control these mussels, and you're currently working on another way. Would you like to talk about either one of those?
Yeah, well, again, I just want to just to recap on this first one, I spent 20 years looking for a safer way that power plants could treat their pipes. And we did have success. And I was kind of hoping that the Environmental Protection Agency would say, no more chlorine. Molloy and his research team have found a microbe, but that microbe doesn't kill 100% of the zebra mussels in the pipes. And when you're a plant operator and you want to kill all of them. So they didn't really switch to this new product. And I wish the people, I'm not commercializing the product, I'm the patent inventor. I did 20 years of research on how effective it is, how to use it, and we found a very, very low environmental impact, and it was commercialized. So that's something that I worked 20 years on. But you always, even then, it's a pesticide against these zebra mussels. If you want to kill them the next year, you got to go back and to that same pipe, etc. But what I'm working on now is a very different approach. What you do is you find a natural enemy, what they're dying of naturally. So my work is done primarily in Eastern Europe, where they come from. And I go there with my research team and we look at what they're dying of naturally. And then we see if those parasites have potential. It's parasites. There are many ways that naturally these mussels die in nature. Predators will eat them, but there's no known predator that only eats zebra mussels. So if you brought in 100 fish of a certain type that eats zebra mussels, after it eats the zebra mussels, it's going to start eating other things in your lake. And then you may have a worse problem than you started with because you can't control them with because again, no fish only eats zebra mussels. That could be used as a biological control agent. But there are parasites. And when you say that word, people get, wait, parasite, we don't want to put a parasite ever into our lake. But the thing is, people don't know that parasites are the most specific of the natural enemies that will kill zebra mussels. And sometimes they're so specific. In nature, there's about 7, let's say, different types of zebra mussels. Let's say that. And all of them are in Europe. There's only 2 of those 7 that are in North America. So what I do is I go to Eastern Europe, see what among those 7, only 2 of them came to North America so far. Okay. And I look at all of them. What is killing them? What types of parasites are killing them? And what I find is the parasites are so specific, they're only killing one of them. The parasite will not kill the other 6. Even their cousins are so close. So that shows you how specific parasites is, in my opinion, the highest chance of ever having a biological control method. Now, again, when I do this work, if I find a parasite that can be used against the 2 species that are in North America, there will be at least 10 years. Even after you find it, it has potential for being used as a biological control agent. You apply it to a lake. You don't have to go back. It spreads on its own, and it will only kill zebra mussels, okay? Once you find that parasite, it takes another 10 years to come up with, if you can, the data that shows its specificity. EPA is not going to allow anybody to throw a parasite out of airplane window into the Great Lakes or any other water body. I'm an environmentalist, okay? That's why I do this stuff. Even after you find, so that's what I'm doing. I'm with a team in Eastern Europe, and we're looking what kills them naturally, and then we see what's killing them naturally. Do they kill those 2 species of the 7 which came to North America, which are in North America? And that's what I'm looking for. And that's what I have to find first. This thing has potential. And then you spend about 10 years demonstrating that it's safe enough. It only kills zebra mussels. It doesn't kill your local frog, doesn't kill your local fish, doesn't even infect them. It's so specific. Parasites are the only natural enemy that have that kind of specificity. There's no predator that just eats zebra mussels. So,
Got it. And we'll come back to parasites. I have a ton of questions on that, but I also have questions
sure.
on different biological treatments. How effective was the highest percentage effectiveness you got of killing mussels?
Yeah. With the product that I'm the patent inventor of, and then some company commercialized it. Again, I have no connection financially with them. 95% was really the highest that when we did tests inside power plants. We stepped it up from laboratory tests all the way up to tests in power plants, and the highest really was about 95%. You see? Yeah, and that just wasn't high enough. If you're a plant operator, you want 100%. So that's one of the reasons probably it didn't take off. It was the most specific. Chlorine or these other chemicals they put in now are not specific, and
Did
they
these
cause environmental degradation.
did these power plants have aquatic life in them?
Sure, yeah. They it's they have all sorts of problems with it's not so much that there are vertebrates like fish living in their pipes, but they have problems with different types of microscopic animals that form slime. You can imagine, like, you go out to any natural water body, put your hand on a rock, it's not going to be clean. It's going to have slime. So when they put chlorine in, it kills the zebra mussels and also keeps their pipes clean. It's not so much what's happening in the pipes, it's when the water comes out of the pipes and then has an impact in the lake or the river because they suck the water in, they add the chemical. The chemical does a very efficient job, and I'm not concerned about environmental impacts inside the plant. It's when the water comes out, it still has that chemical in it in most circumstances. And certainly, if you've got zebra mussels or quagga mussels, their cousin, in your lake, and you put the chemical in, you're going to have a lot of mortality of other organisms. So I'm telling you, I think Idaho is a good example. Again, they are desperate to try to get rid of this quagga mussel infestation, and I believe the name of the river is Snake River. And so they're just biting the bullet and watching fish float to the surface. And that's just what you see, like in terms of fish. The invertebrate community is devastated by this. So the ecology takes the ecological balance in the Snake River is going to take a real hard shot in terms of disturbance. But they're desperate to try to get rid of this quagga mussel infestation, and the odds are against them,
Is there anything you could put in the water that isn't infected to help prevent an infection?
You can put in the water so that the zebra mussels, if they get in, will not become established.
Right.
Is that what
So
you're saying?
I'll specify the question a little more. Let's talk about Idaho and Snake River.
Yeah.
Even if they treat that and effectively get rid of all the mussels, what's stopping them from getting reinfected? Is there anything they can do outside of clean, drain, dry?
You see, this is it's not if it will become reinfected, it's just when, and we all hope it's 100 years later. But yeah, it will become reinfected. See, that's why I'm trying to pull a rabbit out of her hat. What I'm trying to do, the odds are really against me. But in my career, a lot of odds have been against me, and I've succeeded here and there in coming up with biological methods. So that's why you need something you put in there, and that biologic that control method is alive. That can scare people, but I just said takes 10 years of getting data to give the EPA or the local environmental protection agency in your state, wherever you are, enough confidence that this is not a threat. It takes a long time to come up with it. But yeah, it's not a question of if, it's a question of when, because they spread so easily.
Have you successfully treated any water body, whether it be power plant or a private lake or anything, from eradicating zebra mussels?
No, because see, again, I'm the kind of scientist, I develop methods,
Got it.
but I don't commercialize them. I don't go into business for it. I just, okay, we got this. Now I throw the ball to a company. And so there have been cases where they've tried to control. Even with this product, it's called Zequinox, that I'm the patent inventor of, but I'm not involved in commercialization. They've tried to use it in lakes, but I didn't develop it for lakes. It's not very effective in lakes, okay? I developed it solely for power plants, as I said, and so you can get up to 95% kill. But unfortunately, the power plant operators want 100, so they never really switched over. It has been used in golf courses. I know that. But again, I don't follow this because I have no financial interest in the company that is commercializing it.
And then now let's move on to these pathogens you said.
Yeah, a pathogen, you can call it a pathogen, but in really it's alive, so most people call it a parasite. People in the layman would understand more if we call it a parasite than a
Parasite
pathogen.
just it scares people. You know that the word parasite.
Yeah, yeah, it does, but see, I can't help it that, I'm just a scientist that produces data and so I do my best, and then, when things like this are developed, you also need another outreach strategy to describe these parasites. Should I be so lucky to actually get one that could be used, there would be another, I wouldn't be involved in that strategy to go out and explain this to the public as well as the environmental regulatory agencies, that instead of like having the fish float in the Snake River, this thing is a lower risk. There's always risk associated with anything, like even a fly swatter as a control method for your fly. On the backstroke, you can take the chandelier out accidentally. There's always a potential, uh, disadvantage to every method of control. I'm trying to tell a joke here with the fly swatter, but you got to be careful. You don't break something with
So
that control method.
your team goes to Europe, and right now you're looking at these parasites that are eating mussels.
They kill them.
They kill them.
They kill them or they sterilize them.
Is there any water bodies in Europe that has been successful to control the spread of mussels?
See, naturally, now I'm really going to get into the weeds here, so to speak.
Let's do it.
These parasites have been killing these zebra mussels for millions of years. If I find a parasite killing a zebra mussel now in Eastern Europe, that parasite was there several million years ago. And what happens is that when a parasite kills a host, over time, parasite develops a strategy that it doesn't like kill all of the hosts, because if it does, it's out of business too. Do you see what I'm saying? Like, so the parasites naturally, this is what happens in parasitology. Okay? The evolution is not to eliminate your host, because if you do, you're going to be eliminated too if you're that specific. So what happens is if I find this parasite is killing this type of zebra mussel, and I said there's about 7 different types, I test it to see if it'll kill the 2 species that are present in North America right now. Of the 7 that exist in Eastern Europe, again, 2 of them, the zebra mussel and the quagga mussel. The quagga, a lot of people call all 7 zebra mussels, but the 2 species that are in North America, let's just say, that are causing these problems in pipes. Okay, I specifically test a parasite of one of their cousins in Eastern Europe to see if it'll kill the 2 species that are in North America. And what happens sometimes, and this is rare, but it does happen, that parasite, which doesn't kill a lot of the species of zebra mussel that's normally infects in Eastern Europe, when you expose a similar zebra mussel, it hasn't seen this other zebra mussel in millions of years. It hasn't interacted, and it can be hyper killing. And therefore, that's what I'm looking for. I study what kills one of these zebra mussels. There are 7, right, in Eastern Europe. And then I test it against the 2 species that came to North America accidentally, because there is the chance that of the 2 species in North America, they have not been exposed to that parasite in a long time, and it will be hypervirulent. I want to give you an example that most people will understand. When the Spanish came to the Americas, people here, the natives, were Homo sapiens, same species as the Spanish, but the Spanish had diseases. The Europeans had diseases that the Americans, Native Americans, had not seen in tens of thousands of years. And we know the story that these parasites from the Europeans became hypervirulent and killed off the Native Americans. So I'm just, for the layman who are listening to this podcast, like, for example, if there was on the news, they said, oh, in the Amazon, we found this tribe. We didn't know it was there. No one knew it. They say, don't go too near them. Don't intermingle with them. You may give them an infection that'll kill them, right? You're kind of familiar with those stories, right? That's what I use that. I take a parasite of a type of zebra mussel, and then I expose the 2 species that are in North America. Oh, it's all done in the laboratory under careful quarantine facilities to see if it'll kill them, but it'll be hypervirulent. They're not used to it. So I hope that I've adequately explained what I'm trying to do now in my research.
And have you seen any success with that to kill any of these mussels?
We're just kind of getting started in this. We're doing testing in Eastern Europe in the laboratory, like in quarantine facilities, So we're just getting started on that. So yeah, I can say we've been doing it for a year or 2. When you do these tests, you can't do the test and have it like live for a year and then see if they eventually die after a year from this infection. You have to end the test sooner. You don't have enough aquariums to do all the kinds of testing you need to do. So you have to end the test after like 3 months. And then you have to do what they call histology. You have to look inside the tissues of those mussels to see if they picked up a disease that looks like it could kill them. You see, so we have to not only run tests, but we have to actually save a lot of the specimens of these zebra mussels to see if they picked up the disease. They may not have died during the 3-month test. You see? And again, I'd love if we had enough aquariums to just wait a year to see if they die, but we don't. So what I'm trying to say, it takes a long time to try to find something that works, because not only do we look to see if they're dying, but also we look in their tissues to see might they be dying, because we had to end the test pretty quickly in order to bring in more mussels and do more testing of parasites.
And I just kind of want to summarize what I heard you say, and you can correct
Yeah.
me if this isn't accurate. So, as far as biological treatments go, there's nothing that can treat mussels and not affect other wildlife at 100% success rate. And the treatment you did develop has about a 95% success rate.
Yeah, yeah,
Any
and it's best. Yeah.
any other treatments like chlorine, it's going to have effects downstream, and there's no
That's the potential threat. That's the potential threat, you know.
got it. And so there's no biological treatment. There's nothing we can drop in a lake to be able to treat mussels right now, as far as biological stuff, unless you want to put
Yeah.
chlorine in the lake and
No,
kill everything.
nothing is the reason why people say, "Oh, we have an infestation of zebra mussels," and people put their hands up in the air and go, "Well, we can't do much." That's right, you can't do much because there's nothing that is specific enough. Again, use the Snake River in Idaho as it's happening right now. They know it's causing environmental damage. So there's nothing specific enough. And I've been talking to you here for a while. I'm looking for something very specific, a
Right.
parasite, and there's nothing that's cheap enough, because if you have to go back and reapply it to a big lake, it is going to cost a fortune. And you know, it's just a question of time before it becomes reinfected, whether it's a year or 5 years. And you're not going to kill 100% of them the first time you do it. So that's why people accept they have an infestation, and there's virtually nothing they can do about it because there's nothing specific enough and there's nothing cheap enough. And I go back, what gets me out of bed in the morning to do this research that I'm doing is because the only thing that's going to work is something that you put in, and you don't have to put it in again. You put in something live, which only kills zebra mussels in your lake, and it becomes established. And not only does it become established in the cove, the bay you put it in, it spreads. There are examples of this in nature, of this happening, this kind of a situation, of things like that happening. Usually it's kind of bad. You know, someone brings a weed on their boat to a lake, that puts it in one bay, it spreads and cause all sorts of damage. Okay, I'm looking for the good side of that. I put something good in, a parasite that only kills zebra mussel. It can spread, and it doesn't have to be reapplied under the most ideal conditions.
I know we're running short on time, and I want to be respectful of your time here. I just got a
Yeah.
couple closing things here. Is there anything I didn't ask you about that you want to bring up?
Well, the thing is, I know in situations like this in the podcast, people can say, well, what can I do as a citizen here? That is, zebra mussels spread in two ways here in North America or anywhere else. One is they spread naturally. If they get into a water body and that water body's a river, their young are just going to be carried down and down and down. So they can spread naturally once they come into a water body. But a lot of the spread is caused by human behavior. So they attach onto boats, they attach onto any hard surface. So mostly it's boats being trailered from one infested lake because the mussels are on the boat, on the motor, whatever, or their young are inside the boat in the water. You asked me, I think before, how did they come to North America? And I said they came likely in the ballast of transatlantic ships. They're from Europe. So on a small scale, when you have a boat, whether it's a wakeboard boat or fishing boat, if you don't drain, as you said before, clean, drain, and dry, if you don't do, that's your job. So you don't contribute, because that's how they spread large from jumping from one watershed to another. It's human mediated. It's caused by human activity. And that's your job, to minimize the possibility of that.
Do you think there's any chance a bird could be transporting it or anything other type of wildlife?
Yeah. See, in theory, birds could do it. In theory, it could be the immatures get caught up in a water bird in their feathers, but all of the available evidence suggests that that's near zero. Okay, near zero. And I can go into kind of the examples. Yeah, it's 99 point whatever nine is either it's naturally flowing in a river and it's getting into the entire watershed, or it's human made. It's jumping from one watershed to another, and it's the action of people doing that, not so much any animals.
And then the closing question I had is if people want to get in touch with you or see the work you're doing, what's the best way for them to do that?
The best way is I have a website, not that I keep it up to date, okay? But I have a website. So if they put in a search of Molloy, my name, and put in zebra mussels, invasive species, they'll find the website. And then, there'll be an email address there if they wish to contact me. Yeah, on the
Awesome.
contacts menu page. Yeah.
Thank you. And then if I see anything or if you have some breakthrough and you want to come talk to somebody about it, I'm always here. So I would love to hear about
Okay,
it.
anglers insight. That's where I'm going.
So that was our podcast with Dr. Molloy. I found it super, super interesting that he's looking for parasites to treat mussels. I thought we were going to be talking more about biological treatments, but he is the leading researcher by all means when it comes to biological treatments. And it sounds like he's really hoping parasites work out. Thank you for listening. To our listeners, if you found this episode insightful, please consider leaving a comment or review if you're watching on YouTube. Questions, comments, concerns, or confessions, or anybody you'd like to see or any topics you'd like to see covered, I'd love to hear about them. This podcast isn't just going to be about invasive mussels. However, I am going to keep hammering this topic until I feel like I have answered all of my questions and everyone else's questions. I'm just going to keep going on invasive mussels until I have a very good overview of it. My next topic, I think I'm going to cover salmon fishing. I also want to do sturgeon and sturgeon population, but I'm open to any suggestions anyone has. Thank you again for listening. Thank you, Dr. Molloy, for coming on English Insight.